Okay guys, I talked about functions in the last video, so I'm going to continue with where I ended, that the function can call another function or itself for that matter. Let me demonstrate this with very simple example. Let's say we have some print the numbers. And I'm going to specify input and output all the numbers. Let's say I specify 3 and I'm going to output 1, 2, 3, similar to some loop. We need the parameter. Let's see, input. Now in the last video I didn't mention that you can have multiple parameters, as many as you give, like maybe I can have this, I can have this. These parameters can have different types. But let's talk about recursion. Now, let's call this print numbers and then have input and then -1. We need to call print numbers and then we specify, let's say 3 as we agreed. Now what will happen? Now let's see. Sometimes I give good examples, sometimes I give bad examples. As you see, we get Stack Overflow. Why? Well, because this function is calling itself forever. You need to specify some end condition. Okay, let's do this. If input equals 0, then return 0. And let's visualize okay. And we get our input 3, 2, 1. Okay. You might be wondering, okay, what's the point of this? I mean, like, isn't it possible just to write some simple loop? And yeah, sometimes it's better to use a loop instead of recursion. Sometimes it's better to use recursion. For example, in my opinion, when you have some tree and then you have something like this, and then this has something like this, and this has something like this, and then you get the idea, And maybe you want to go here, then go here, then go here, and I find it very useful to use recursion in this case and not use some loops. Now, what kind of problems you can solve with this recursion? Well, let's see. Let's print, factorial. What is factorial? Well, let's say I give you 5 and then you do something like times 2, then times 3, then times 4, then times 5, and this will give you something like 120. Let's do this using this recursion. So we have factorial and return input times factorial input -1. And then we have some int, which is output, and then we have this one. And let's break here. And change the name to factorial. Let's see what happens. Output is equal to 0. Well, why? Because we specified to return 0. This is like our base case. Let's fix this. Now it's equal to 6. Okay, let's see what's going on. We go here, and I want you to pay attention to the call stack, how the call stack grows. So now input is 2, then it's 1, and we go here, and that's all. So we have 1, 2, 3. Let's see how it grows, like with more numbers. And you see how it grows. Well, we saw this exception with Stack Overflow. Like the stack is not unlimited; it has some size. So you see, with each recursive call, the stack grows, and pay attention. This is why we have this case, and if you call this function many times, the stack grows, and then there is some overflow. And okay, maybe you wonder what's going on, like where is this stored, what's going on, and many such questions. I'll try to explain this as best as I can. It's let's see first maybe the stack. What is this stack, by the way? I've been talking about this stack. Well, the stack is some structure, like it is in the computer memory, but it's like a stack of books, and you have this, and you have this, and you have this, and you have this, and these blocks have similar size because this is this function, and we have integer, and we have integer, and we have integer, and you get the idea. integer has some fixed size, so this is equal to this one, and so on and so on. So these blocks have equal size. And you know, we have some case where we store in the stack that how was it? It was like we have this stored, then we have 2 times 3, and then it stores like sorry. So you get the idea, you know. Basically, we store these values in the stack, like each execution of this function of this factorial gets stored. And then when we end, basically we have the result of 1 times 2 times 3 times 4 and then times 5. So in the end we have we have the result, and this is why it was very important in the end, you know. If we go back here, you know, we have 1. So what is this one? Well, this is the base case. So this base case also gets stored in the stack. Like if we have 0, then we will multiply and get the wrong result. So this is why we have the base case 1. And this is also to prevent, as we said, you know, this is to prevent some infinite growth of the stack when it reaches some, let's say, limit case, and then, you know, you go over this limit. So this is all there is to know about recursion. As I said, you know, you can have you can solve some similar problems similar to loop. Sometimes it's better to use loops, sometimes it's better to use recursion, depends on your case. And yeah, you know, thanks for watching.